Good morning, everyone. This is Kumar. Today, I would like to explain about graph traverses. Graph traverses is a technique used for searching vertex in a graph. A graph traverse is also used to decide the order of vertices is visited in the search process. A graph traverse finds the edge to be used in the search process without creating loops. Without creating the time of search, you cannot create the. That means using graph traverse, you visit all the vertices of the graph without getting into looping path. Means visiting at the time of visiting all the nodes, do not create loop. That is the main important point. Mainly, the graph traverses are two techniques, DFS and BFS, depth first search and breadth first search. There are mainly two types of techniques. Visiting of the all the nodes, that is called a traversing. The first one is depth first search. This is DFS. DFS travels of graph produce a spanning tree as final result. It means visiting of the all the nodes without creating the loop at the time of travels, graph produce the span, the final result. Spanning tree is a graph without loops. We use stack data structure with the maximum size of total number of vertices in the graph to implement DFS travel. It means uh, the number of vertices are equal to size of the stack. The how to visit the travels using DFS, the algorithm, the following steps. The first step, define stack of size, total number of vertices in the graph. It means the initially to count the total number of vertices and create the stack. The step 2, select any vertex as a starting point for travel. Visit that vertex and push it on to the stack. It means depending upon the graph, you can choose any vertex for starting. That point or insert to the stack. Third step. Visit any one of the non-visited adjacent vertices of vertex, which is at the top of the stack and push it on to the stack. It means the first choose one vertex, then the adjacent vertices, non-visiting adjacent vertices, and then push to the stack. And step 4. Repeat the step 3 until there is no new vertex to be visited from the vertex which is at the top of the stack. And step 5, when there is no new vertex to visit, then use backtracking and pop on the vertex from the stack. It means backtracking means nothing but the previous visited vertex. At that time, the present top value to pop. Okay. Steps. Repeat step 3, 4 and 5 until stack becomes empty. To empty, the 3 steps are repeated. Finally, when the stack becomes empty, then produce final spanning tree by removing unused edges from the graph. It means after the completing of the visiting, it means the stack is empty. For example, I am choosing some 7 vertices and undirected. In this, select vertex A from starting. I am choosing vertex A for the starting of the vertex. So mark that A, and at the same way that visited vertex is pushed to the stack. That is the first step. Then the present I am choosing A. Then step 2, the present visited vertex existing non-visited vertices. The non-visiting vertices is D, E, B. In that 3 existing vertices, I am choosing B. So B also mark, and then the B is pushed into the stack because of the B is visited vertex. Then after that, again the B check the non-visited vertex. In that, the E and C is the non-visited vertices. In this, I am choosing C. So C is marked and C is pushed into the stack. The C existing vertices G, F, and E. The any one you can choose, but I am choosing E. So E or push into the stack. Then the E existing addresses B, A, D, and F. But the C, B, and A already visited. But I am choosing only for the non-visited. Non-visited addresses only for the D and F. In that, I am choosing D. So mark the D and push into the stack. Then again check the D adjacent vertices. D adjacent vertices A and E, but both are visited vertices. So using backdrop means the previous vertex. So backdrop is representing for the red mark, that is E. So this is popped. Then check the E adjacent vertices A, B, C, and F. But the A, B, C are already visited vertices, the F only non-visited vertices. So move to F and push into the stack. Then F adjacent vertices E, C, and G. But C and E already visiting vertices, G only non-visiting vertex. So F to move G. So G are inserted into stack. Then G adjacent vertices C and F. Both are visited vertices. So using backdrop, that means previous is visited vertex. That is F. So G is popular. Again F. Check the adjacent vertices E, C, and G. But all are visited vertices. So using backdrop, that is E. So F is pop. Then E vertex are checked. E vertex D, A, B, C, and F. All are adjacent vertices, but all are visited vertices. So backdrop using to C and E are pop. Then C adjacent vertices B, E, F and G, but all are visited vertices. So no non-visited vertex. So using backdrop, that is B. So C are pop. Then check the B adjacent vertices, that is A, E and C. All are visited vertex, no non-visiting vertex. So using backdrop, that is move to A. So B are pop. Then A are adjacent, check the A adjacent vertex. So that is D, E and B. All are visited vertex. No non-visited vertex in A. So move to backdrop, that is non-porous. That means they are pop. The finally the visiting vertices, the graph, that is called an a DFS. That means the final result is showing that is called an a spanning. Clear? Thank you.